This lesson will show you how to design a question and hypothesis for an authentic science learning experience. Every authentic science experience starts with a question. Anything from why does popcorn pop to how old is the universe? This question provides the impetus and the context for inquiry. And it makes the experience impactful and meaningful for your students. It also addresses NGSS Scientific and Engineering Practice Number 1, asking questions, and the first step of practice number 3, planning and carrying out investigations. But coming up with the right question to launch your science experience can be hard. You want it to be interesting and engaging, but you also need to consider where it fits into your learning objectives, curriculum, and standards, and if it's the kind of question you have the resources, time, and skills to answer. So don't be surprised if you update your question at least once while designing your science experience. There are strategies that will help you find the right question and the right approach to answer it. Start with clearly defined objectives for your science experience. This will establish the scope of your question. You may want your students to demonstrate and apply specific knowledge, build specific skills, or address specific standards. And so ask a question that relates directly to a particular subject matter or standard and requires them to use a particular skill. Or you may want them to gain experience more generally, or explore something they are curious about. And so make your question broader. Whatever the scope of your question, make sure it's clear and specific. A vague question won't provide enough direction for you to design a successful approach to answer it scientifically. Try to start your question with a scientific inquiry word, like how, what, or when, who, which, why, or where. And keep the question simple. If you can't write it down in one short sentence, it's probably getting too complicated. Avoid general, unfocused questions, for example, asking how acids work. Instead, you might want to ask what happens when an acid is placed together with a base. You can always build on your first question to get answers to bigger ones. If you're struggling to formulate a suitable specific question, check out Rutgers Riot. This interactive video takes you through the process of selecting your research topic and question. Once you have your question, you need to figure out how to generate a scientific answer to it. This can be tricky. In everyday life, we often answer questions based off hunches, inference, and partial information. Scientists answer questions rigorously by showing cause and effect relationships or correlations they can support with experimental evidence. These relationships can be described by a sentence that goes as follows. If this happens, then this will happen. For example, if I want to know what will happen if I add acid to base, a scientific answer would be, if I add acid to a base, then the solution will be neutralized. Or if I am curious why puddles disappear faster in the summer than in the winter, a scientific answer might include, if the air temperature goes up, then the rate of water evaporation goes up. It's critical that you tackle your question in a way that will generate a scientific answer. Which is why scientists start by generating a hypothesis about their question, and you should too. Generating a hypothesis addresses a key part of NGSS Scientific and Engineering Practice Number 3, planning and carrying out investigations. A hypothesis is an educated guess about what the scientific answer to the question might be. It is often written as a cause and effect statement, one that you will try to prove or disprove through experiment. This means your hypothesis has to be testable. It has to involve factors or traits that you can measure or observe in an experiment. Sometimes it's quite straightforward to formulate a testable hypothesis. Adding different types of seeds and counting birds at a feeder can certainly be done. Sometimes you have to think about it a bit more. Can you really determine when gum loses its taste? Sometimes it's very hard or even impossible. Can you measure happy? Can you prove it's due to the hamburger? This is often the case with questions that address opinion, feeling, or behavior. They can be fascinating, but typically are hard to get solid scientific answers to. To create a useful hypothesis, you'll need to understand the topic your question is about quite well. Remember, it needs to be an educated guess. Completing research also supports NGSS Scientific and Engineering Practice Number 3, Planning and Carrying Out Investigations. There are many online resources available that can help you research a science topic. The generic ones, like Google and Wikipedia, you likely know and use routinely. They are easy to access and use, but they don't always yield results that are equally easy to understand and apply. Instead, you may want to use research tools that are designed specifically for education, like Instagraph. These filter and structure results to make them easier to use in the classroom. After you collect information on a topic, it is often useful to organize it into a model of the system that you are studying. This will help you understand how it works and often makes it easier to come up with a good testable hypothesis. Building a model also supports NGSS Scientific and Engineering Practice Number 2, Developing and Using Models. A simple visual way to do this is to create relationship maps between the facts that you have uncovered. Tools like Poplet let you build and share these maps easily. And some like Instagraph even do much of the work for you. However you set about defining your science question and hypothesis, don't spend too much time on it. As you move along to design your authentic science experience, you'll quickly figure out if your question and hypotheses are holding up or not. And if your initial question and hypotheses fizzle out, don't hesitate to refine them or develop new ones.